in that chunk. The head is pretty standard to zlib compression, and then the end, which is usually used for zlib, is an Adler 32 checksum. And they just happen to look like it. So we went ahead and gave it a try without even, I think we didn't have DZ at our disposal at the time, but we used just some quick Ruby to prove that, to see whether it worked or not. And we were successful. So this is what we got out of our extracted protocol. So we talked a little bit about how to break up those messages. I'm going to talk a little bit more because I think we slid by a little bit too much. But I want to talk too about what this gives us. We've got this protocol pretty much understood at this point. All right, we haven't understood it yet because we don't know what the message fields are, but we're looking at what we need to mess with. And that's an important accomplishment right there. If you can do this, and if you can tell that to your vendor, that right there is a concern, because I can guarantee you that the reporting protocol is a key factor of extrusion detection. And if you're able to see what it looks like this easily, and for that matter, probably send it back to the server, because bear in mind, we talked about why authentication isn't necessarily going to be a viable option for extrusion detection. You've pretty much got something on your hands right here. And this is definitely an avenue worth approaching. So the protocol here, we weren't able to break this up as much as I would have liked to, but we talked a little bit about the length and content segments that you're likely to see. If you're looking at this and if you can see it, basically what we've got is several fields in here. I'm just going to go through them really quickly. There's a username, a file name, and then a big chunk of data. And in between those, there are also some integer values. You can tell, if you look at the first 4 bytes of that hex num, this is little endian, bear that in mind, because that means that probably everything else in the packet is also going to be little endian. You probably would have been able to tell that from the header, but theoretically, the header could be big endian and the compressed segment little endian for whatever reason. So it's good to just verify your endianness. The first integer, you wouldn't know this from looking just at the packet, but through doing other analysis, and bearing in mind what this packet has to contain, the first integer is going to be your ID that identifies the rule that triggered this alert. The second is going to be an ID that correlates to some metadata surrounding the user. And then, so at this point, we're about 8 bytes into the packet.
This is about as technical as we're going to get, and actually we're going to pick it up because we're running low on time. And there's
so I'm going to pass through this real quick, but the rest of it is basically lengths and lengths specifying the length of the next field, and those are the actual text fields that you might want to mess with along with the lengths. Okay, so what does this accomplish for you? Being an agent lets you generate arbitrary events, possibly and most likely malicious ones, against the extrusion detection system. And also bear in mind that the reporting database is a database, which means that there's a high probability, at least in the case of Plugboy, that it ends up in a SQL database. So this is another avenue in addition to web attacks that can result in SQL injection. So try things like that out as well.
We're going to talk a little bit more about how the UI and how the UI is exposed to attacks from the agent as well. But what's funny about this, the fact that the protocol is not encrypted? I mean, okay, it can generate spoofed alerts, no big deal. But it's picking up information out of SSL sessions from browsers, the most sensitive information on your entire network. It's collecting credit card numbers, files full of credit card numbers. And what it does is it bundles that information up in a reporting packet and an alert, and it sends it over the network, and you've just translated what was used to be a secure HIPAA-compliant session over your network, and we found this in a variety of different systems, including Plugboy. The fact that people don't seem to realize that just because it's in a reporting message doesn't mean that the regulatory requirements for that information somehow changed. So you really do care whether that protocol is encrypted or not. That's an important question. In fact, there's only one question to ask your vendors about how they're encrypting the channel between the agent and the server end. Is it TLS? If they give you any answer besides it's TLS, it's the wrong answer, because TLS is an incredibly complicated protocol. It's hard to implement these things correctly. Every encryption protocol that you look at that isn't TLS is riddled with vulnerabilities in crypto and message handling and transactions. The only one the only one that you can trust has actually gotten it right is TLS. Windows comes with built-in TLS. They should be using it. They should be using client certificates and server certificates on both ends. You want to mandate that whatever extrusion detection product you deploy on your network is TLS or SSL secured, so that you know that the most sensitive place that they collect information from, that the channel that they use to report that information is at least that secure. And then we're going to keep moving at a pretty rapid clip through the rest of these slides now.
All right, I do want to touch on encryption real quick here, because like authentication, if you are using authentication, what are you keying it off of? Similarly, if you're using encryption, what are you keying it off of? Ultimately, the agent has to know those keys. So there's a possible argument that there's really not a lot of value. However, I agree with Tom. It should be at least going that extra step to do it, because you can take this protocol and understand that, yeah, if you have the keys, you can reach it from a malicious agent, but you don't want it to be casually visible in the network. We had at least one developer for one of these products make this argument with us.
Let's go through this really quickly. So as reports are sent to the system, they're collecting forensics information to put this stuff in context. Next slide. Well, here's an interesting thing. The Plugboy system that we looked at had the capability to update the forensics information after the fact. Every alert that was sent by the system had an alert ID. And the system stored the alerts in an SQL database, and it trusted the alerts as they came in over the reporting protocol. And if you had duplicate events in the system with the same event ID, the more recent data overwrites the previous data. So what you can do is the attackers can overwrite the information in the central console. They can basically go and change what happened in history and erase the evidence of their attacks. Or they can use the same protocol, of course, to insert malicious evidence that will mess you up when you actually try to do it. So don't assume the fact that a report actually landed at the server is the end of that particular transaction. In Plugboy and in other systems, it's possible to open that data back up and change it as long as you have enough credentials to actually pretend to be an agent and talk back to the server. In other words, as long as you're any one of the 1,000 devices on your network that you deployed the system on. So we cover that? So, how are we authenticating information? How are we making sure that the information, you want to ask your vendor, once the alert data gets there, how are we making sure that that data is kept safe and is tracked and has not been modified and can't be erased by an attacker? And then here's probably the final major vulnerability thing we want to talk about here is the fact that the Plugboy system, like almost every system you're going to look at, has a web interface. It's a JBoss, Java-based, JSP servlet, web application, just like every other enterprise management UI in the entire world. And so you inherit all the basic web vulnerabilities with the system. So naturally, you want to ask, who actually did the external penetration test on their web app? That's a shrink wrap service that you can buy from any of 100 different companies that will do web app pen tests on things like enterprise management agents. You'll be surprised when you look at systems like this. They're authenticated. They might have Radius support or Secure ID support to log into them. But if they don't get the web app stuff perfect, you have forced browsing attacks that'll get you to pages after the login page, even without logging in. That's a type of vulnerability you're going to find. But there's a more important vulnerability that you find in a lot of extrusion detection systems, and almost in most of them, especially if they have web interfaces, is, we might have it on the next slide. The problem is that these systems are collecting complex information from the environments where they're generating alerts from. And that information includes things like OS strings pulled from the operating system, or the actual details like who was the card holder for a credit card when it actually got transmitted over there. Well, the problem is it has to display that information to the user. And when it does that, people that write web apps get good at output and input filtering data to make sure they scrub HTML tags and script tags out of data when it comes in from the HTML side of things, when it comes in from the HTTP side of things from a browser. People are getting pretty good at that. What people are not good at is checking the unconventional or unexpected channels that information comes into the system from. So what we find in Plugboy is that if you generate an alert where the card holder name has a script tag in it, well, that script tag is going to be executed in the context of the browser of the admin when they actually view that alert. They're not going to notice it, though, because the script tag isn't going to display anything. It's just going to seize control of the admin's browser and feed the cookie that they use to log into the system back to the attacker, who now owns the management console that has the privileges to log into 1,000 agents on the network and turn the agents installed onto your network from a latent botnet infection to an active botnet infection that's actually going to take over your entire network and destroy you. So all the information coming into these systems have to be vetted the same way as if they were coming from an untrusted attacker feeding data into the system. It's not just, cross-site scripting vulnerabilities and script tags embedded in it. It's also things like, as the data comes in, these are hard to test for too, SQL injection, right? The system tries to key things off like, I'm going to key it off by the operating system version. And I trust the operating system version because I asked Windows to tell me what the operating system version was. And the attacker backdoors their agent, gets the operating system to have like a single quote in the name that wasn't where it was expected. And now you've broken out of it an SQL query that was used to actually index the alert properly by operating system, for instance. Now you own the database that the system uses. That database probably includes the login, so now you own the management console, and now you own 1,000 systems across the entire network. Or you can erase previous events, or you can get extra data out of it. But almost every single web attack that you can launch against a system through a web browser can also be launched through the reporting protocol. And you don't even have to be able to break the authentication of the reporting protocol to do it. Remember, these systems are installed on 1,000 systems on your network. If 0.01% of the people that have these agents get their boxes rooted, those boxes can be used to take over the rest of the network through the management console. So, predictable questions. Again, we'll get this to you guys in hard copy or soft copy online later. But how has the management interface been vetted? Where are things filtered? Ask the vendor to tell you specifically at what points input has been filtered and what it's been filtered for. Force them to answer that question, which will probably force them for the first time in the development of the product to actually apply input and output filtering to prevent that system from destroying your whole network. Another thing to look for is that a lot of the times the file formats that are being used here are complex, and they launch files they launch file format viewers. And now you have this whole problem of untrusted or malicious documents being viewed in file formats where malicious documents can actually be used to take over the system. Does the thing have file format viewers? Does it launch external programs to view files? Is one of those external programs going to allow them to execute programs? That's a plug-boy vulnerability. So these are things that you have to ask and worry about, is that the event information, it could lie and say that there's a fake event and frame somebody. It can erase a previous event, or it can also be used to take over the management console, which is game over for your entire network. I think we could probably wrap it up here. And one thing that we did was we went a little bit over time here, so I want to make sure if there are questions that we actually get a chance to field them for you for the first time in a BlackHat talk that I've ever given. Questions, anybody? Questions are your way of proving that you paid attention. Yeah, over there.
Well, I want to say I paid attention for us. You talked a lot about this. You talked about agent things you mentioned that we talked about. And correct me if I'm wrong, but it sounds like you're at least cynical about the agent-based ideas in general. So have you looked at the client-based?
Yes.
Do you feel that they're any better or worse, or what's your thoughts?
That's a great question. So the question was, have we looked at appliance systems as well as agent systems? The answer to that is yes. And because I'm lame, I'm still not naming names. But we, for instance, found an appliance in this space where we had the archiver vulnerability, right? As files went through, it would unpack zip files and look at it. And we were able to overwrite arbitrary files and take over the appliance. I would have a hard time answering the question about whether vulnerabilities in the network appliance are scarier than vulnerabilities in the endpoint. The endpoint sounds a little bit safer at first because it's like, well, there's only one of them. If you compromise it, you just get one machine. But the problem is those vulnerabilities are transitive. And once you've compromised an agent, chances are, in 80% of the cases, you get the management server and everything else. I'm probably, if you push me, a little bit more scared of agent-based or endpoint systems than I am of the network systems, because assume that you're going to lose the system, period. What's the worst case if you lose the appliance? You got one vantage point in the network to look at packets. So we've looked at them. They share some of the same kinds of vulnerabilities. In particular, all the file format and data intercept and parsing vulnerabilities exist there as well. But I got to go. We'll be around.
Thank you.
Thank you.